A heat pump for the production of domestic hot water is a technology that achieves significant energy savings compared to other systems for water accumulation and hot water production. Water heaters with heat pumps require installation in places that remain in the range of 40 to 90 degrees Fahrenheit, 4.4 to 32.2 degrees Celsius, throughout the year. The energy savings, compared to an electric water heater, are estimated to be between 50 to 75%, depending on the coefficient of performance in heating mode, COP, of the heat pump. Parts of the heat pump. The air-water heat pump consists of two parts: the heat pump unit, located at the top or compression cycle, and the accumulation tank at the bottom. The heat pump is based on harnessing the energy produced by changes in the state of the refrigerant fluid through a compression cycle. A compressor, whose work enables the development of the process, as it reduces the volume of gas, facilitating the release of heat by increasing its temperature above that of the medium to be heated. For this work, it requires electrical energy to transform into mechanical energy. B condenser is a heat exchanger always located at the outlet of the compressor, through which the refrigerant fluid in vapor form gives energy to the water in the tank, because it is thermally hotter than the refrigerant. As it releases energy, it condenses the refrigerant back into a liquid state, while the water heats up with this heat. C expansion valve is a component of the compression circuit, through which the refrigerant fluid passes, and through its change in section, it causes a sudden reduction in pressure, which, when descending, produces a drop in the evaporation temperature. Electronic expansion valves are commonly used. D evaporator is another heat exchanger, located at the outlet of the expansion valve, which, through its surface expanded by a fin system, and by having reduced its evaporation temperature below the external air temperature, allows the exchange between the refrigerant fluid and the external air. In this heat exchanger, the refrigerant fluid changes from liquid to a saturated vapor state. In these systems, the use of refrigerant gas R-134a is common, although the R-290 gas is beginning to gain ground. For example, if the temperature of the external ambient air is 7 degrees Celsius, we can expect an evaporation temperature for R-134a of around 0 degrees Celsius. Therefore, the low pressure in the system will be 2 bar, very close to 30 pounds per square inch. However, if the required temperature for hot water is 55 degrees Celsius, a higher temperature in the condenser is needed, in this case, around 65 degrees Celsius, where a high pressure of 29 bar, about 279 pounds per square inch, is required.